Welcome back, everyone. Ready to dive into something a little bit mathematical today?
Hopefully not too intimidating, though it does have a name that can sound kind of scary. The bell curve.
Right. But I promise it's actually super interesting and helps us understand so much about the world once we wrap our heads around it.
Absolutely. It's one of those things that might seem abstract at first, but it's incredibly useful.
Okay, so maybe for our listeners who haven't encountered this before, what exactly are we talking about when we say bell curve?
Well, the bell curve, also called the normal distribution, is all about how things tend to cluster around an average. Like think about if you lined up everyone in a city by height.
Oh, yeah, you'd have like most people kind of in the middle.
Right. Fewer and fewer folks as you get to the really tall or really short ends of the line. The bell curve is just the way we show that pattern mathematically.
So like a graph.
Right.
With that classic bell shape.
Yep. The highest point of the bell is the average, and then the curve slopes down on either side. The further you get from the average, the less likely something is.
So in our height example, average height is the peak of the bell. Makes sense.
Mm-hmm.
But how did people even figure this pattern out? It seems kind of fundamental.
The history is actually pretty fascinating. It goes back centuries, really. Mathematicians and astronomers started noticing these patterns in their data, but it took a while to really formalize it.
I was going to say, it's not like someone just suddenly shouted, "Eureka, the bell curve."
No. More like a gradual process. Lots of smart folks building on each other's work. Abraham de Moivre, Carl Friedrich Gauss, these guys were big players in the math behind it.
And now it's like Statistics 101, right?
Yeah.
I vaguely remember it from school, but
Yeah.
it felt very theoretical back then.
Yeah, I get that. But what's cool is that once you do understand it, you start seeing bell curves everywhere in real life.
So let's get to those real world examples. We've got height, but what else? Like surprising things where this pattern pops up.
Well, we can stick with humans for a sec. Think about weight. Same idea as height. Most people cluster around an average, fewer at the extremes. This is hugely useful for things like, I don't know, clothing companies.
Oh, right. That's why some clothing sizes are way more common than others they're designing for the average, where most people fall on the curve.
Exactly. Makes sense from a business perspective. Got to cater to where the most customers are, probability-wise.
Okay, so humans get it, but what about nature in general? Like beyond just us?
Oh, it's everywhere. Lifespans of certain bugs, even like the size variations in raindrops, often follows that bell-shaped distribution.
It's kind of wild. Like even when things seem random, there's this underlying order.
That's part of what makes the bell curve so powerful. It helps us see those patterns, make predictions about how the world works. And the key to a lot of this is something called the central limit theorem.
Oh, yeah, I've heard that thrown around. Sounds intimidating, though. Can you break it down without making our brains melt?
I'll try. Basically, it says even if our starting data isn't a perfect bell curve, if we take a bunch of samples and average them, those averages will start to form a bell curve. It's like this weird force pulling everything towards the middle.
So even if individual data points are all over the place, their averages kind of settle into this predictable pattern.
Pretty much. And that means we can use the bell curve to make predictions, even when things seem messy at first glance.
Super useful, I'm starting to see. But are there ever times when the bell curve just doesn't apply?
Oh, for sure. It's common, but not universal. Some situations need different distributions altogether, but understanding the bell curve is like a good foundation. Helps us grasp how data generally behaves.
Like a starting point before things get more complex.
Yeah, okay.
Okay, so big picture. Why should we care about the bell curve? What's the takeaway?
Well, it helps us make sense of the world. Why are some things common, others rare? It gives us that framework. And then making decisions based on probabilities.
Instead of just seeing things as totally random, we can sort of guess what's more likely to happen.
Right. That's useful in tons of fields. Scientists predicting experiment results, businesses forecasting sales, even stuff like traffic patterns or weather forecasting.
Okay, yeah. I'm starting to see bell curves everywhere now. It's kind of blowing my mind a little.
That's the fun of learning these concepts, a new lens to see the world through.
So we've got humans, we've got nature. What about something like scientific measurements? Do those follow this bell curve thing too?
Oh, absolutely. Think of it like this. You're a scientist, right? And you're trying to measure something super precisely, like, say, the length of a leaf.
Okay, I'm picturing it.
Even if you're like the most careful scientist ever, there are always going to be these teeny tiny variations in your measurements.
Yeah, you might hold the ruler a little differently each time or...
Right, or the leaf itself could even shift a tiny bit. And all those tiny differences, those measurement errors, they tend to follow, you guessed it, a bell curve.
So I like made a graph of all the measurements.
Most of them would cluster around the true length of the leaf. With fewer and fewer measurements, the further away you get from that true value.
So it's like the errors themselves aren't totally random. There's a pattern.
Exactly. And knowing this is super helpful for scientists because it means they can interpret their data better. They know that even with those variations, they can still get a good estimate of the real value.
By looking at the average, right. Okay, this is seriously cool. So we've got heights, weights, lifespans of bugs, raindrops, even scientific measurements. What other, like, crazy examples can you think of?
Well, how about something like IQ scores in a population?
Yeah, I've heard about that. Like, most people score somewhere in the middle, and then...
Fewer people at the super high end, fewer at the low end, right? Another classic bell curve. Helps us understand how abilities and traits are spread out.
This is making me think, what about, like, athletic performance?
Yeah.
Would that follow the same kind of deal?
You got it. If you looked at, say, everyone's times in a 100-meter sprint, you'd probably see that bell shape again. Most people clustered around an average time, fewer people way faster or way slower.
Man, it's amazing how this one curve keeps popping up everywhere, like a universal language for how things are distributed.
I know, right? It's a pretty fundamental concept in statistics and probability, for sure.
So we've talked a lot about how the bell curve helps us describe patterns and make predictions, but I'm curious, are there, like, deeper implications? Does it tell us anything about how things just gaudy?
Whoa, that's a really interesting question. One thing it definitely highlights is this idea of balance. Think about that peak of the curve where most of the data hangs out. It's sort of like the average, the middle ground.
Yeah, the point where things tend to settle.
Exactly. And in a lot of ways, it reflects how systems in nature just don't work. There's this constant back and forth, this push and pull that often leads to a kind of equilibrium.
So even with all the chaos and randomness out there, there's this underlying tendency towards balance.
Exactly. And the bell curve helps us visualize that balance. It shows us that extremes are less common, while the middle ground, the average, is where things tend to stabilize.
Whoa, that's kind of profound. It's like the bell curve isn't just math, it's a reflection of, like, the universe itself.
I love that. It's this reminder that even in all the complexity, there's often a simple underlying order. And the bell curve helps us see that order in the midst of all the randomness.
This is totally changing how I see things. I'm going to be looking for bell curves everywhere now.
I bet you'll be surprised at how often they pop up. Once you start noticing them, you can't unsee them. Kind of like learning a new language, suddenly you hear words and phrases you never noticed before.
Great analogy. So as we keep exploring this concept, anything else we should keep in mind? Any other, like, key takeaways or implications?
Well, I think it's important to remember that the bell curve is a super useful tool, but it's not, a crystal ball. It can help us predict the likelihood of things, but it can't tell us exactly what's going to happen.
Right. It's all about probabilities, not certainties.
Exactly. And that's a really important distinction. It gives us this framework for thinking about probabilities, for understanding what's possible, but it doesn't eliminate the element of chance and surprise that makes life, life.
Yeah, that's a good point. Even with all our fancy models and tools, there's still so much we don't know and can't fully predict. Always room for the unexpected.
Absolutely. And that's part of what makes the world so fascinating. It keeps us guessing, keeps us learning, keeps us exploring.
This whole conversation has been so insightful. I feel like I have a much better grasp on the bell curve and what it all means now.
I'm so glad to hear that. It's been a pleasure chatting about this with you.
And to all our listeners out there, we hope this deep dive has been as illuminating for you as it has been for us. Keep those bell curves in mind as you go about your day. You might be surprised where you spot them. So, wow, we've really uncovered a lot about the bell curve today, how it helps us see patterns, maybe predict some things, and even that idea of balance in nature. It's pretty amazing.
I know, right? It's this awesome concept that kind of brings together math, nature, even like philosophical ideas.
Now, earlier you said the bell curve isn't like a perfect predictor, right? It's about probability, not knowing for sure what'll happen. So I'm wondering, are there any times when we shouldn't rely too much on the bell curve? Like when it might not give us the whole picture?
That's a great point. One thing to remember is it works best when we've got tons of data, and that data is pretty random and each thing is independent of the others. If those things aren't true, the bell curve might not be enough.
Okay. Can you give me an example of that? Like when the bell curve might lead us astray?
Sure, let's think about something like trying to predict how an election will turn out. Polls can be helpful, right? But they often make assumptions about how people will vote, and those assumptions might not always be true. Unexpected events, people voting strategically, even just the way a question is worded. All those things can mess things up in ways a bell curve model might miss.
Oh, I see what you mean, like those X factors that can change everything.
Yep. And in a lot of real world situations, those X factors are super important. The bell curve is a good starting point, but we got to consider context, the little details, and be ready for surprises.
It's like that saying, no battle plan survives contact with the enemy, right?
Exactly. Things change, we got to adapt. What about something like the stock market? Predicting that is notoriously difficult, even with all the fancy models they use.
Yeah, the stock market is like the ultimate example of a complex system, right? So many things going on.
Totally. It's a great example of where the bell curve can be useful, but definitely not foolproof. So many factors are all jumbled together, economic stuff, what people are feeling. It all affects those prices in ways that are, well, pretty hard to predict.
So in the end, it sounds like we need to use the bell curve carefully as a guide, but not like it's the only answer.
Exactly. It's all about balance. Like imagine using a map to go somewhere new. The map is super helpful, but it's not going to tell you about every bump in the road or if there's like construction blocking your way. You still need to be aware of what's actually happening around you.
Love that analogy. So we got to use these models, but also be ready to think on our feet, right?
Right. Use the bell curve as a tool, but don't let it limit your thinking. Be open to those real world complexities. That's where things get really interesting.
Well, this has been a fantastic deep dive. We've learned so much about the history of the bell curve, how it's used, what it's good at, and even when we need to be careful with it.
Totally agree. It's been a blast exploring this with you.
And to everyone listening, thanks for joining us. We hope you've enjoyed this deep dive as much as we have. Keep those bell curves in mind as you go about your day. You never know where they might pop up.
And remember, even when things seem totally random, there might be some hidden order underneath it all. The bell curve helps us see that order and appreciate the elegant simplicity that can come out of complex situations.
We'll see you next time on the deep dive. Until then, keep exploring, keep learning, and keep asking those curious questions.